Welcome back to some more geometry. Today we are talking about two-dimensional figures. So let's go over some background information here. So two-dimensional figures are anything on a flat surface. We talked about this back in chapter 1, but we call these irrational or undefined terms or undefined objects because technically there's no one set value, one set look to what a triangle is, what a square is, what a rectangle, all that stuff. So let's kind of look at the whole idea of these. So polygons, that's what these are. Polygons are our shapes. Polygons come from the Greek word polygonos, which means many angles. There's a bunch of angles here. As you can see, you can have just 4 angles on both of these, or this has 1, 2, 3, 4, 5 main angles, plus these big obtuse angles right here at the edges. So this is a polygon. Now, why is this considered not a polygon? It's a good question, right? Anytime the sides of a shape intersect with each other, it's no longer a polygon. It's gone out of its definition because now it's crossed out of its own self. Right here. So that's the main difference between what's a polygon and what's not. So at any point, if you have let's say you have a nice triangle, but then it continues out, it no longer is considered a polygon. As a whole, this is no longer a polygon. You can maybe consider two different things where you have a polygon with an extended ray, but it's no longer a polygon. Now, polygons comes in different classifications. This is one style. We can classify them as convex or concave. Now, convex polygons are such that, this is a convex, by the way, convex, this one right here, and the other one is a concave. Concave. All right, we'll start with the convex. There's a whole definition here, but picture-wise, imagine you have your center right here. And then every single angle as you see are going outwards, away from the center. Now you see all these angles? They're all going away from the center. They're convexing outwards. They're going away, so it's considered a convex. But a concave, think about it like just that. When you see a cave, you walk into it. Even though they tell you don't go in there, there's bears, you go into it. So concave. There, as you can see right here, the angle is going inwards towards the center. It's almost like we took this side and pushed it in to form this star. So it's concaving inwards. I don't think that's a proper way to just use the word concave, but it is concave. It's going inwards, so that's considered concave. Think about it kind of like a house. You have a house. It's built up nicely. This is a convex house. But what happens if your roof caves in? You now have a concave house. It went inwards. Ha 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 ha. So that's one way to categorize polygons, either convex or concave. These are the terms that we use to describe the polygons. We classify polygons by their sides. Now, most of us know this, but FYI, a 4-sided figure is called quadrilateral. And we will spend a whole chapter speaking on quadrilaterals because there's something special about quadrilaterals. You have your rectangles, you have your rhombus, you have your trapezoids. You have so many different quadrilaterals. But we don't call all 4-sided figures a square. We don't call all 4-sided figures a rectangle. We just call them quadrilaterals. Now you got your pentagon, your heptagon. You got your pentagon, your hexagon, then you have your heptagon. This is a unique one that we don't speak very much of. A heptagon. Sometimes in a different book, they call them septagons. So depends who you're talking to, the Romans or the Greeks. You got your octagon. This is a new one right here. Most of you guys haven't seen too much. It's a nonagon, a decagon, a hendecagon, a dodecagon. Usually past that. Now there is a name for every single so many sided shape thing. So like a 22-sided figure has a name. Do I know the top of my head? No, I can Google it probably. But past 12, we usually just use a number. So if you're talking about a 13-sided figure, you usually see it referred to as a 13 gon. If you're talking about a 27-sided figure, you call it a 27 gon. If you're talking about a 175th sided figure, it's called 175 gon. So like I said, there's actual names. Like a 1,000-sided figure is called chiligon, a million-sided figure is called megagon, and a 10 to the 100 power sided figure is called a googolagon. So there is names for these things. Continue on. This is another category we can classify our polygons. So polygons can be considered equiangular, equilateral, or regular. Let's see what's the big difference. So equiangular, think of the key roots here. Equiangular means equal Angles, yeah. Polygons that have all angles to be congruent, that are exactly the same, are considered equal angular. Equilaterals, if you're not sure where your lateral muscles are at, they're the sides of your body. So your lateral muscles. It means all sides are congruent or equal. Now, if it happens to be both equal angular and equilateral, we call those regular. It's a regular polygon when both it's equilateral and equal angular. Here it's a very irregular, weird one. Here is a equilateral because equal angular, sorry. All the angles are the same, but not all the sides are the same. Here, all the sides are the same, but not all the angles are the same. On this particular one, not only are all the sides the same, but all the angles have the exact same measure. So this is our example of a regular polygon right here. This is a regular polygon. All right, so that's the first part of this assignment in this lesson. It's just classifying these polygons. How do you classify them? What do they mean? How are they? Okay, the next part of this assignment for 2-3 is area. We're going to look at area. So we talk about perimeter. We're going to talk perimeter. Perimeter is pretty simple. We don't go too deep into that. It's just you're going to add up all sides. Okay, however many sides you have, you're going to add them up. So if it's a hexagon, you're going to add up 6 sides. If it's a dodecagon, you're going to add up 12 sides. Now, area, there's specific formula for areas for each polygon. We're going to look at 3 areas, 2 unique ones, but a third one that kind of relates to that. And then we're going to talk about circumference. Now, circumference and perimeter are basically the same thing. Again, perimeter, you're looking the distance around a shape, but circumference is specifically distance around a circle. Now, question for you guys. Why do we not call the distance around a circle also a perimeter? Yeah, there's no sides to the circle. You have to have sides to have a perimeter. If you don't have sides, then you have circumference. Correct. So let's talk about triangles. So triangle, the area of a triangle is pretty simple. It's base times height divided by 2. You might see it as BH over 2, or sometimes you see it as 1/2 BH. There you go. My thing's freaking out. All right, so pretty simple. It seems base times height divided by 2. But let's talk about specifics here. Looking at this triangle, what has to be unique and special about the base and the height is they have to form a perpendicular together. So here we have a right angle between this height and this base. All the heights come from the opposite angle away from what we're considering the base. So that does matter right here. So the base and the height have to be perpendicular. Now, sometimes you get nice little right triangles. Let me draw you one real quick. Nice little right triangle. It goes straight up and down that way, and then across this way really nicely, and then diagonal. You have a right triangle, so it makes a right angle right here. So this can be considered your height, and this can be considered your base. Unlike this one where it has the angle on the inside. All right, but what happens if you have an obtuse triangle? Let's draw an obtuse triangle. It's going to go like this, and then we're going to go way out here, and then way out here. There we go, right there. This is, let me fix this right here. Right there. We have an obtuse triangle right here. Let's look at this problem right here. So we're going to consider this down here our base. So this side right here, from here to here, will be our base. Now our height has to come from this angle, and it has to be perpendicular with this side over here. But there's no way to do it anywhere inside. As you can see, it will never make a right angle. So what are we going to do? That's a good question. So what we're going to do is we're going to extend this side out. We draw dashes, or you can do a solid line. I use dashes right there. We extend this out to where it's still straight with that side, and then that way we can then make a perpendicular straight down with the opposite angle to form a right angle right there. Now, this is going to be your example to use here. Let's assume they tell us that this side right here is a 6. Let's say that's 6 right here. This right here is an 8. This right here is a 10. And then this distance over here is 12. The question is, what is the area? So take a second to do the area of this. All right. So hopefully you paused, did it. Now, when we look at this, we know, like I said earlier, this for sure is the height. Now, common mistake that I saw when we were doing this in class is they say, hey, the base is 20. But it's not. It's not 20. You got to understand the base is just the actual part of the triangle. So it's this 12. This is my base. Even though we had to extend this side to ultimately find this right here, whether it was by Pythagorean theorem or just because it was given to us, we cannot include this. We cannot include this as part of our base. It's just an extension to create the height. So when we do this problem, we'll do 6 times 12 divided by 2. Alright, you do 6 times 12 divided by 2, you get 72 divided by 2. You end up getting the area of 36 units square. 36 units square. Pretty simple, right? Alright, let's look at our next shape. Our next shape is a rectangle. We will spend a whole chapter on quadrilaterals, but right now we're just bringing the simple shapes because you will run into this as you work through your assignments in later chapters. Alright, so rectangles are just base times height. No dividing by 2. Now you got to think about it. You can divide a rectangle into 2 triangles. So technically it's base times height divided by 2 and base times height divided by 2. Well, if I have 2 of the exact same, there's no reason to divide by 2. That's where the base times height comes from. Alright, now let me erase this because I'm going to do some moving around. So we have this shape right here. We have base and height, and we also talk about length and width. Now the difference between the two, maybe, I don't know if anybody has explained it to you besides me, but the difference between the two is very important. Now the base and the height will always go the way they are. Base will always go side to side. Height will always go up and down for the most part. In the homework, there is one problem that is slanted like that. I still consider this my base and this is my height because it's closest to it. This still looks very tallish. But if we were to turn this up and down, where the long parts on the side and the short parts right here, this is still the base and this is still the height. It doesn't matter. Like a building, the bottom is still the base and how high it is still the height. So that's what's very important about base times height. Now let's talk about length and width. Length and width always goes with the sides. So the long side is my length, the shorter side is my width. So if I were to turn this shape like I just did right now, up and down, these values will go with it. So this is now, let me go back to that. Change back to my pen. This right now is my width, and this over here my length. So you can see those traded spots as far as where we had them originally. But it doesn't change the value that you still have one value on one side and another value on the other side. So looking at this as a practice problem, you can consider this my base and this my height. Even though the base is up here, understand these both are bases in a rectangle and these are both heights. But you only need one for the area. So find the area of this particular problem. Hopefully you did 3.2 times 2.1 and you got 6.72. And that's 6.72 units square. Alright, so that's a rectangle. Pretty simple. I got pretty technical because I want you to know like the background information behind that. Let's look at a square. So square technically can work just like a rectangle. You can take the base times the height and that's your answer for area. But what about if it's not like that? So let's look at this. It is like that. Let's look at this particular example right here. We got 4 sides. All 4 sides of a square are the same. Okay, side, 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 side. That's what makes a square unique. It is. So that's why we consider the area side square. Because if I take my base right here, which is S, times my height right here, which is also S, I get S times S, which gives me S squared. That's why we use side square. The reason that's relevant to us right here is because there'll be problems where they tell you something like, hey, my area of my shape here is 49 units square. What's the perimeter? Well, you ask, like, oh man, the area is 49. How do I get the sides? That's a good question. Remember, area is equal to side square. So if they tell us my area is 49, that's equal to side square. How do I get one side? Well, how do we get rid of any square value? What's the opposite of a square? Oh, what's a square root? So we square root this side, we square root the other side. We end up getting 7 on one side, and the other side we just get our S. So we find that each side right here is 7 units. That's why it's very important to kind of understand that area of a square can be taken as just the side square in this case. So, practice problem. What's the area and the perimeter of this problem? So, what's the perimeter and the area? So, pause a second, do that, and we'll compare answers. I got perimeter of 20, because we did 5 plus 5 plus 5, so 20 units. And then I got area of 25 units square, 5 times 5. So, hopefully we get the same thing there. Alright, You will run into a problem very similar to this one. I think yours is tilted the other way. It's going to ask you to find the perimeter area of this problem right here. All right? Perimeter is pretty simple. It's side plus side plus side plus side. Okay? But we got to find those. And here's the thing. These are on a graph. And we say, well, how long is that? How long is that? And how long is this side? We know for sure that this side, the two opposite sides are equal to each other. So we have that. But how are we going to find the side? That's a good question. Hopefully you remember a little thing we call the distance formula. Understand, when they ask you for the length of something, especially on the coordinate graph, it's also like doing the distance, because you're finding the distance, how far is it from one point to another. So the distance from here to garden is the same thing as saying, hey, what's the length from here to garden? It's just one word sounds weird because we're not used to hearing it. So distance and length are work the same in that same formula. So as much as we call this the distance formula, we can also call it the length formula because it's doing the same thing. It's finding how far it is apart from 2 points. So as you remember, our distance formula goes, it's x2 minus x1 squared plus y2 minus y1 squared. And the whole thing is square rooted. So we'll take a minute and we're going to do this right here. So let's do this one together, and then I'm going to just give you the answer for the other one because it's a whole long process. So we'll call this x1, y1, x2, y2. All right, we set it up. We say, hey, we got our 1, so we do 1 minus a negative 4. Remember, don't use this negative as that negative. They're two different negatives. Quantity squared plus 7 minus 2 quantity squared. We work this out. We end up getting 1 plus, I'm going to change the colors so it doesn't confuse you. 1, because it's double negative, it makes it positive. 1 plus 4, you get 5 squared. And over here, we got 7 minus 2. We end up getting 5 squared. You square them both, you get 25 plus 25. Understand, this whole time, this is under one big radical. So we have a bad habit of dropping the radicals, and you guys will give me the answer of 50. So we got to keep our radicals. So 25 plus 25, we get radical 50. Now this does simplify the radical to be 5 radical 2. I got this answer because you asked the question, what perfect square number is in 50? Well, we just happened to do it earlier. There were 25. So you can say, hey, radical 50 is radical 25 times our radical 2. As we talked about multiplying radicals, this is just a breakdown of the 50. And the square root of 25 is 5, but there is no square root of 2, so it stays as a radical 2. That's where we get this answer from. But if you want to go ahead and put it in a calculator, you can put radical 50 or you can do 5 radical 2. This will round off to be roughly 7.07. And I think in the homework it does tell you to round, so we'll say this is 7.07. And because this is 7.07, so is the other side. So you don't have to do the same process again. You will, though, have to do the distance formula between a height side, so from D to C. When you do it, you get roughly 5.656, so we're going to say 5.66. We'll round it to 2 decimals. Okay, we'll go ahead and add those numbers together. So on my calculator, I did 7.07 plus 7.07 plus 5.66 plus 5.66. You end up getting 25.46, and that will be my perimeter. My perimeter is 25.46 units. Okay. Now for area, like we said, this is a rectangle still, so we will do 7.07 times 5.66. It's a little bit bigger number, so 7.07 times 5.66, we end up getting 40.0162. So we're going to go 2 digits, so it'll be 40.02. Alright, and that is our area. This is a unit square. Alright, I think the one on the homework, you have a rectangle one as well, so it wouldn't be too bad. Let's look at the rest of this, and we'll be done. So we're going to talk about circles. Now, first we're going to start with the circumference. Now, this is the technical definition of circumference, but the idea behind this definition is this. A long time ago, before circles were a thing, we said, all right, we got to find a way to figure it out, because we've been talking about this whole polygon business. How are we going to define a circle in relation to what we already spent a long time working? Well, the idea behind circles is that they make tons of tiny individual little triangles that all meet at the same spot. Well, they did so many of them that it just kind of eventually comes to a point where it fills that circle up. They say, all right. So the circumference comes from a pattern of the distance from the center to the base of this triangle, and then we're going to multiply that to a certain amount. It's very technical, and actually there's a really cool video on that. I might link this on here, but this is the formula for circumference. Is you're going to take 2 times pi, and this pi, man. This pi is what makes circle circle. It what makes circle circle. It's a very unique part, and we talked about pi before. Pi is it's an irrational number because it never stops. There's so many digits in pi, but we're used to hearing 3.14. Oh man, there is over 100 billion numbers that can be extended out, and that's how far I think they've calculated to. I think it's gone further. I might Google that later and see, but we're gonna leave pi as pi for now. So as you look at this, you have 2 times pi times the radius. That's the formula that we're gonna use. Now I'm gonna tell you right now, always leave your answer in pi form until the very end. So if it tells you to round, don't use 3.14. Use the pi button on your calculator. It would give you a long distance number, and then you can figure it out from there. All right, so let's look at this. So what is the circumference in this problem? So the circumference, the radius is 4. This is 4, the radius. So let's put it in a formula. So we got 2 pi radius. That's the formula we're going to use. So we're going to use 2 times pi times 4. We multiply our two numbers, we end up getting 8 pi. Unless it tells you to round, that's a perfectly acceptable answer. You say, all right, 8 pi, that's a great answer. But let's say they want you to round it to 1 decimal. I think on the homework, they ask you for the nearest 10, so 1 decimal. So we're going to take 8 times the pi button. If you're using an iPhone, you can turn it sideways, and the pi button will be in the bottom row in the middle. If you're using an Android, you can just slide your keyboard over, and it should be there. But on my calculator, I have an 8, and I literally have a pi button, and it looks exactly like that. When I hit enter on my calculator, it gives me 25.13234, etc. Okay, so I'm going 1 digit, so I'm going to go just to 1. So this will be 25.1 units. That's how far it is around this circle. Pretty simple. Remember, use your pi button. Don't use 3.14. For area, very similar to area, we're going to take the value of pi and then our radius squared. Now, make sure, this is a big habit that I see. Make sure you square your radius first and then multiply by pi. So, let's do this particular problem in pi form first. So, our radius is, as you can say, 6. That's our radius. So, we'll do pi radius square, or pi times 6 square. Now, you square that, you get pi 36. Proper notation, you put the 36 in front, so we get 36 pi. This is unit squared. This is a good answer right here. Now, they did tell us to go ahead and round to the nearest tenth. So I'm going to literally take 36 pi. So 36 and the little pi, hit enter, and get a number, and I get 113.09733. They wanted us to round it to the nearest 1 decimal or tenth, so we're going to go 113.1 units square. And that's our proper answer right there. Again, don't use 3.14. You will run into a coordinate plane problem here on your homework. You will have to do the distant one on yours, but I'm not going to do it. Here's the thing. I'm not going to do it on this one because, luckily, for some reason, this incredible math teacher of yours happened to put the center and the edge of the circle on the same level. So we can just count over on our plane. So we can go 1, 2, 3, 4, 5. The distance, our radius, is 5 units. So hopefully that helps you find your circumference and area. Circumference, if you do it correctly, I'm going to let you guys pause and do that. But if you do it correctly, you should get 10 pi, which then rounds out to be 331.4. And then when you do area, you end up getting 25 pi, which I think that's 78. Let me double check. 25 pi. That is 78, roughly, estimate, 78.5 units square and units right there. All right. Hopefully that helps, and I'll see you guys the next day. Bye.